Okay, this is the second factor, effect of pH. Now you have to remember this graph on pH. So it is the rate of reaction against the pH. So from 0 to 10. 7 is neutral, below that is acidic, above 7 is alkali. So pepsin, still remember pepsin? This is one of the enzymes that will catalyze protein. Okay, it will break protein into smaller substances. So optimum pH for that is pH 2, that is very acidic. So where can you find pepsin? Yes, you're right. It is in the stomach. It is in the stomach. Okay. So we have this gastric juice, which is very acidic. Okay, for the work of this pepsin. Okay, next, let's look at the red one. This is pH for salivary amylase and most enzymes in animal cells. Mostly it is at neutral. Okay, neutral. Salivary amylase. You know what is saliva, right? Ileum. Okay, so if our saliva is not neutral, what will happen? Can you imagine that? Right? Uh, okay, next is optimum pH for trypsin. Okay, trypsin is also another enzyme to catalyze protein. Okay, but this one is a little bit alkali is needed. Alright, now look at this figure first. Molecule of a denatured enzyme. So this is in a three-dimensional form, as I mentioned just now in the effects of temperature. So when it has denatured, you see it has broken, the chemical bonds is already broken. Okay, so we said that it has denatured. Okay, it has denatured. So enzyme activity is influenced by the pH of the surrounding solution. Okay, react most effectively at their optimal pH, but mostly it is between 6 and 8. That means this is the one lah, right? Okay, however, there are some exceptions. So exceptions you have to remember. Okay, optimal pH range between 1.5 2.5 is talking about this pepsin. So trypsin enzyme in duodenum, on the other hand, only works well in alkaline medium. Okay, in the duodenum, remember earlier on I mentioned about duodenum being the first part of the small intestine, and it is alkaline in medium. Okay, it's talking about this. Okay, now the change in pH value changes the charge. We know that this is H plus. H plus is acidic, right, of the active site of enzymes and the substrate surface. So as a result, the enzyme substrate complex cannot be formed. Okay, so that means charged change. pH value changes the charged. Okay, pH value, we are talking about as acidity or alkalinity, so that's why you have this H plus over here. But when the pH of the environment returns to optimum level, the charge on the active site will be restored, so the enzyme will return to function as normal. Okay, so we don't say that, usually we don't call it denatured lah, just that we say the environment not suitable. Okay, but when you return it back to the optimum environment, then it is suitable. What will happen is the charge on the active site restored, and we say that the enzyme function as normal again lah. Then the extreme change in the pH value will break the structural chemistry bond. Denatured enzyme. Okay, extreme, anything extreme yang berlebihan sangat. Okay, usually this one is on the extreme temperature. Okay, very high temperature.